H on A.
Okay.
And also force A on B.
Well,
That'd be,
so you do it in the order that it's acting on. So if it's on A, then it would be B on A.
oh, B on A, okay. That's small, or is it the same size? It's equal, or is it smaller?
How would you know?
It's accelerating,
Right.
so it's smaller.
Yep. It has to have a net force to the right in order to accelerate.
B on A. Block B would be bigger. And that would be so that would be B, A on B.
Right.
And then the other, it goes the other way, but it's smaller. You have force B on A. Right.
So B on A is on A, right? A on B would be on B.
Oh,
Is there anything that's
No.
slowing B down?
no.
So that's block B. And what about your hand?
Your hand has A on H.
Right. And then you ignore the force that's actually pushing it forward.
Okay.
So which ones are action-reaction pairs?
Action and reaction would be F H on A and F A on B.
Right, so which one goes with H on A?
Oh, we'll go with F A on H.
Right. Those two are action-reaction pairs.
And then it'd be F B on A and F A on B.
Right. So that tells you to rank them.
There's a lot of these action reaction pair rank. Order all horizontal forces from largest to smallest, yeah. So the larger one would be FH on A equals FA on B.
Is it equal to FA on B or FA on H? So you look at your reaction pair.
Oh,
So it's A on A, or A on H and H on A are equal to each other.
so FA on H
Right.
are equal.
Yeah, because that's what if they're an action-reaction pair, and that means the hand is pushing against A, and A is pushing back with the same amount.
Oh, okay, right, okay. And that is, would that be greater than that B on A?
Yep, because they're speeding up.
Yeah. says if the surface has friction.
Okay.
So we just add friction, right?
So A and B have the same coefficient, kinetic friction, yeah. So you'll add friction in there. So let's see, I'm just gonna add it in a different color. So which ones are gonna have friction on?
FA on B.
Oh, I just switched to, so the hand doesn't have any friction, right?
Right.
So you're just gonna throw some kinetic friction A on here, and then some on B as well. So how are you gonna rank those two? I guess first, will any of this stuff change? Because it's still speeding up.
That would be the, those are still equal.
So we'll know that FA on H still has to be bigger than both of these
Right.
together. So A on H is still equal to H on A, which would be greater than B on A, which should be equal to A on B. So you know that this one's gonna be bigger than these two. Do we know whether or not this force is greater than our friction or not?
Which force?
Our-
FA and on B.
A on B or B on A?
FA on B. The FA on B would be greater, because it's accelerating.
So it has to be greater than this friction.
Yeah.
Okay, so we could put that in there. I don't know if that's the notation they use, is it? No, it probably just lets you pick them yourself. Okay? So how would you find out which one of the frictions is bigger?
Do you figure out if they're bigger?
Yeah, so which friction's gonna be the largest? What's the equation for friction?
K equals,
It's the normal force times the coefficient of friction. So it tells us the coefficient of friction for A and B are the same. So the only thing that could change would be the normal force. So which one will have a bigger normal force?
FA on B and FB on A.
Well, we're just talking about the blocks themselves. So the normal force would be a vertical.
Would they be the same?
If you did the free body diagram for them, the only vertical forces you'd have mg and the normal force on each of them. So then you can compare mg, which one has a greater mg?
That will be.
Yeah, because
It's a bigger mass.
it's got more mass, yeah.
So the normal force will be.
So if the normal force is greater, that means the friction's greater. So you can put friction A at the end. So you know that these two are equal and they're greater than this one because this has to be greater than these two put together.
Alright.
Then over here, we know that A on B is going to be greater than the friction of B. And then we also know that the friction of B is greater than the friction of A because of the masses. So when you Yeah, friction, that's the only thing that's,
So whenever like the mass is bigger, then it's usually, the friction is bigger, cause it's more, has more weight on the ground.
right, as long as the coefficient of friction is the same, and as long as those are the only forces in the X, because if you were pushing on something like this, then that's gonna contribute to your friction.
Right.
Kind of like if you're pushing a chair across the floor, it's different if you're just pushing on the back of it versus if you're like pushing down on it. You can feel the difference. It's a lot harder to push it when you're pushing down on something.